This is question number 14 from the Fall 2013 Algebra and Sample Materials. Use the data below to write the regression equation y is equal to ax plus b for the raw test score based on the hours tutored. Round all values to the nearest hundredth. So we have x values, 1, 2, 3, 4, 5, 6, 7, and we have raw test scores or our y values. We're going to have the calculator calculate for us the linear regression equation. We're going to press stat, enter for edit, and in L1 we're going to put in the hours tutors or our x values, and in L2 we're going to put in the raw test score or the y values. So our x values are 1 through 7. Our raw test scores are 30, 37, 35, 47, 56, 67, 62. Now we're going to press stat, right arrow to calc, scroll down to linear regression, ax plus b, press enter. Our x list is L1, our y list is L2, that's correct. We don't have a frequency list. We don't need to store the regression equation because we don't care how it looks when it's graphed. All we care about is the equation. We're going to scroll down to calculate and press enter. The calculator calculates for us the linear regression equation. Y is equal to ax plus b. So y is equal to a, they tell us, is 6.32 rounded to the hundredths, x plus b, which is 22.43. The next part of the question says, create a residual plot on the axes below using the residual scores in the table above. So to graph residuals, we graph the x values, and instead of graphing the y values, we graph the corresponding residual values. So for an x value of 1, we have a residual of 1.3. That would be a point over here. For an x value of 2, we have a residual of 1.9. That would be over here. An x value of 3, we have a residual of negative 6.4. An x value of 4, we have a residual of negative 0.7. An x value of 5, we have a residual of 2. An x value of 6, we have a residual of 6.6. An x value of 7, we have a residual of negative 4.7. And this would be our residual plot. The next part of the question says, based on the residual plot, state whether the equation is a good fit for the data and justify your answer. So this line is a good fit for the data because if the residual plot is scattered randomly and relatively evenly above and below the x-axis, it means that the residual plot is a good fit. If, let's say, we would have a residual plot that ended up looking like a parabola or some other pattern, then it would be a bad fit. But since this residual plot is random, the line of best fit is a good fit for the data.